These are the preview exercises for College Algebra Lesson 15. So below is a graph of f of x. We want to use that graph to graph g of x, which is 3 times f of 2x on the same set of axes. So we're going to start by changing the coordinates of the 5 key points, a, b, c, d, and e, according to the transformations that have been applied to f. So the transformations are this 2 on the inside and this 3 on the outside. Okay, so the 2 on the inside is going to transform the x coordinate because it's inside the function with the x, so, which means it's horizontal inside. Because it's multiplication, it's going to be a stretch or a shrink, and inside horizontal changes always are kind of the opposite of what you expect. So you might think that this would double the x's, but in fact, it's the opposite of that. We have the x's. Okay, so to transform the x coordinate, I'm going to make a little note here. I'm going to do x divided by 2. Instead of multiplying by 2, we actually divide by 2, or times a half. You take half of the original x. Now the other transformation is this multiplication by 3 on the outside. Outside changes are vertical changes, and vertical changes are exactly what you expect. So this is 3 times the y value. Okay, so outside changes are vertical, so we're going to change y by multiplying it by 3. So here we're going to take y times 3. Okay, so here are my key points, a, b, c, d, and e. I've written down their coordinates. -6, 5 is the coordinate of point A. And then I'm going to transform the x's and the y's according to these rules. So we divide x by 2, and we get -3, -1, 0, 1, 2. We triple the y's, and we get 15, 3, 21, 9, 15. So my corresponding points on G are -3, 15, -1, 3, 0, 21, 1, 9, and 2, 15. So we plot them to draw the final graph. So -3, 15, -1, 3, 0, 21, 1, 9, and 2, 15. And then we connect them with straight lines because that's how the original was connected. Okay, now we just have a few questions about what happened. So the domain of f, the original function, would be smallest x to biggest x. So it would be -6 to 4. I'm including the endpoints because those dots are filled in. And the length of that domain, the distance from -6 to 4, is 10. So the length of that domain is 10. And the domain of G, so G goes from -3 to 2. And the length of that domain, the distance from -3 to 2, is 5 units. Okay. So how did the length of the domain change? Halved. Okay. It's half of what it used to be. Okay, now let's see the range. So the range of f, the smallest y is 1, the biggest y is 7. So 1 to 7. And the length of that range, the distance from 1 to 7, is 6 units. And then the range of g, okay, let's see, the smallest g is 3, and the biggest g is 21. So 3 to 21. And the length of that unit is 18. And how did the length of the range change from 6 to 18? It tripled. So you can see the domain and the range followed the rules of what happened to the x coordinates and the y coordinates. We halved all the x coordinates that caused the domain to halve. and we tripled all the y coordinates, that caused the length of the range to triple.